The world ends around you, living through cracked screens. We fall down to what we want.
This is a short explainer on the simple power outage tracker. For the purposes of this setup, you would need at least two devices. One would be an SSID broadcaster. For my case, I've used this device called ESP8266, and the other thing you would need is a server which periodically performs Wi-Fi scans to check the Wi-Fi signal that is broadcasted by the ESP8266. The reason we've chosen ESP8266 is twofold. One, it's cheap. Number two, it is programmable. And the programmable part is the important part, which would be explained a bit later. Now, two important notes here. You would need to have your ESP8266 connected to the main line, so when the power goes out, this gets knocked down, and that way we can get reported that there has been a power outage. The other thing, you would need your RaspberryPi or whatever server you have connected to a UPS and then connected to the main line, and the same goes for your internet connection, which is going to report you through notifications, for example through if this then that or some other notification method. So these are the things that are required. An obvious con to this approach is if the internet goes down while the power is down, then you wouldn't be able to get a notification. For those cases, there are already alternatives available in the market which use SIM cards and perform messaging through mobile operators. The reason why you cannot use a non-programmable device, which is either it can be a Wi-Fi repeater or a router, is because it would not be able to handle certain scenario. Let's say you have power at 7 a.m. and you have a power outage happen at 7:01 a.m. The power then comes back on at 7:03 a.m. and you have a 15-minute window where your server checks, performs a Wi-Fi scan. So when the power comes back on at 7:03 a.m., the server will still report as if the power never went out. But if we want to report this scenario, which is the power went out in this short duration, then we would need to add a delay, the same amount of time as that of the period that we scan in, which is in my case it's set to 15 minutes. You can set it to whatever time you like. So even if the power goes off at 7:01 a.m. and comes back up at 7:03 a.m., the 15-minute delay, which is programmed into the ESP8266, and this would basically take care of that edge case. When the power comes back on at 7:03 a.m., it gets reported, or it gets back, the device gets back up at 7:18 p.m., which is 15 minutes later. That way, the power outage would get reported at 7:15 a.m. So yeah, this is the short explainer for the simple power outage tracker. Okay, now coming on to the setup that you would be requiring for ESP8266. I will leave a link in the description which will help you out setting your ESP8266. Basically, you'd need to go into file preferences, set up a URL here, and then go into tools, add a certain library. That will all be in the link that I will list in the description. Once you've done that, you would need to at this point connect your ESP8266 via a USB cable. That will be a mini USB to USB cable, and you'd also need to ensure that the USB cable that you're using allows for data connections, and some of the cables only have charging capability, so make sure that that's not the case, because I thought my ESP8266 chip was bad, or it had something had gone wrong with it, but turns out the USB that I was using was bad. Just paste the sketch that I will be posting a link to in the description and hit upload. Once you have that, you would need to go to your server, which is in my case the Raspberry Pi. You would need to run a shell script and run it periodically, as we had mentioned. This will be the script that you would be running on your server. So this name could change based on the configuration that you set here, the SSID and password, and you would also need to change this specific line if there is some other method other than IFTTT that you're using to get notified about your devices. Make sure you change the key as well as this trigger word. In my case, I use power outage just to keep it simple. And the script will also do one little cool thing, which is it'll keep a log of power outages, so that you can check back on it whenever you like and see if it's performing well. So for the past 2 or 3 days, I've been trying it out and it seems to be working well as logging all of the power outages that happened. To make sure that your program runs periodically, that it scans periodically, you would need to set up cron. Now to do this, I would recommend using the sudo cron instead of the normal cron, because while scanning the Wi-Fi, the commands that we use, they require sudo privileges. So just type this in, sudo cron tab -e. You'd be brought, if you're doing this for the first time, then you would be brought to a screen which asks your preferred editor. You could choose Nano, which is what I'm doing in my case, by pressing 1 or just pressing enter, which is selected by default. And when you scroll down to the bottom, you wouldn't see 2 of these lines. You'd probably see nothing written here except these comments. So just add this last line, which and make sure that you place it in a directory that is corresponding here, and this is what will run it by cron. So what this means is it will run every 15 minutes of every day of every month and every year, whatever. This is basically it. This is a short explainer, and all of the other resources that you see in this video would most probably definitely be listed in the description. Hope this was helpful to some of you out there, and if there are any other ideas that could enhance this project, or maybe something that can be added onto this project, please comment them in the description so that I can make another video on it based upon your ideas. That's it for this video. I hope to see you guys in the next one.